Hello, it's dumplet here. Here's an item on number theory. N is a positive integer such that n minus 1 divides n plus 2n squared plus 3n cubed plus so on and so forth until 2021 n raised to 2021. Now the question is, how many values of n work? Credits to the Art of Problem Solving community for this item. As usual, pause this video if you'd like to give this item a try. But if you're done, let us dive into the solution. Now I will write something equivalent to this one, this given. So since n minus 1 divides this thing, I can say that the n plus 2n squared plus 3n cubed and so on and so forth until the 2021, n raised to 2021. If I take it under modulo n minus 1, I should get 0. Just because, well, it's divisible by n minus 1, so it's going to leave a remainder of 0 when divided by n minus 1. So this is the equivalent statement under the modulo. Now we can kind of use some nice properties in modulo because n over here is actually congruent to 1 because n leaves a remainder of 1 if I divide it by n minus 1. So I can say that n is congruent to 1 modulo n minus 1. And this will have nice things because I can replace all the n's, as you can see here. I can replace all the n's with 1's, as you can see here. And if I do that, everything here, so the 1 plus 2 times 1 squared and so on, that just becomes 1 plus 2 plus 3 all the way until 2021. And this is one of the common series in my common series part 1 video. The card is here above. Now, from that video, there will be a given formula, and we would be able to get that this is just equal to 2021 times 2022 divided by 2. And we can do some cancellations here. So it's just equal to 2021 times 1011. Now, we have 2021 times 1011 mod n minus 1, and we know that what we want 0 to be congruent to this. So again, we can try to rephrase this. We would want to have n minus 1 to be a factor of 2021 times 1011. So now the question kind of turns into, I want to find the factors of 2021 times 1011. Now we can do some kind of logic here because, well, n minus 1 will be the factor. So n would just be the factor plus 1. So I don't think this will violate the fact that n won't be a positive integer. So we can actually just say that, the number of positive divisors of this number, the 2021 times 1011, that's also going to be the number of positive integers n that is going to work in the original statement. So we're just kind of interested in factoring this now. So let's try to do that. Now, 1011, there is an obvious factor of 3 because the sum of the digits is 3. And you guys can find that it's actually equal to 3 times 337 for now. And then the 2021, there's actually a nice way to factor this because 2021, that's going to be equal to 45 squared minus 2 squared. And, well, 45 squared is 2025, and then 2 squared is just 4. So it is equal to 2021, and this is just a simple algebra trick. We can use the a squared minus b squared factoring trick, and this is going to factor into 45 minus 2, and then the other one is going to be 45 plus 2, and that's going to actually give us the two factors of 2021, and you'll be amazed to realize that this part is just equal to 43 times 47, both of which are prime numbers. So it's a little bit more difficult to get, but this is one of the nice ways that you can factor 2021. Now, the last thing to worry about is the 337, and it's just an exercise on your part. You guys can eventually find that, well, 337 is indeed prime, so there are no other smaller prime numbers that divide 337. Alright, so now that we have n minus 1 is a factor of this number over here, we just want to count how many positive divisors does this number have. Now it's nice that it's already in our prime factorization, so all we have to do is just use this method. The link to how to get the number of positive divisors will be in the card above as well. Now, since we have 3 raised to 1, 43 raised to 1, 47 raised to 1 and 337 raised to 1. I'll briefly talk about it here. We're going to take the exponents and then increase it by 1. So since we have 4 1s, we're just going to have 4 2s after adding it by 1. And to get the number of factors, simply multiply these numbers that we have. So 2 raised to 4, and if we know what 2 raised to 4 is, that's going to be 16. And this is going to be our final answer. So this is a number of positive integers n, such that the original condition will be correct. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye!